Biotic and fossil fuels.
Yes.
All parts?
Yes.
Fossil fuels are like a million little volcanoes going off. Each of our cars is taking rocks and making them into gas.
Yes.
Okay. That's nice. So then all we have left for today is one study goal, number 19, the nitrogen stuff. And I have a lot to tell you about nitrogen stuff. First of all, you have to know what these nitrogen chemicals are, what the compounds are. So I'd like to point those out to you. N2 is called nitrogen gas. It has a few other names. People call it atmospheric, diatomic, or molecular nitrogen. That's N2. Correct. Nitrogen gas is atmospheric, diatomic, or molecular. There's another compound that shows up in a few places. It's NH4. That's called ammonium. It's the ion of ammonia. Ammonium, NH4. You have to know all of these. NH4 is ammonia. When you see the two A's, that's not a chemical compound, that's an acronym for amino acids. Like FBI, that's not a chemical compound, it's Federal Bureau of Code. AAs is amino acids. That's not a chemical formula, it's an acronym. So that's amino acids. And the last chemical symbol that's on there, bros? The last chemical symbol that's on there is nitrate, NO3. You don't have to know why we call them that. You don't have to know anything special about them. But at this level, you just need to know that the symbol has that word corresponding to it. So gas, ammonium, amino acid, and nitrate. Only a few different ingredients. Are there any questions about that? Next. Please look up. This is above ground, and this is below ground. We only see this stuff because this is what we usually do on the day-to-day life. And this is all done out of view, in the ground. Does anybody remember from the macronutrient study goal why you need nitrogen? Yes?
In your DNA?
That's right. We use it to build DNA. We also use it to build proteins. So basically, you need it for almost everything that you do in day-to-day life. Here's the frustrating part. I'd like everybody, when I get to 3, to take their breath and hold it. 1, 2, take a breath, hold it. Right now, your lungs are 71% nitrogen gas. It's almost 3/4 of your total lung volume, and you need those nitrogen atoms for all of your proteins and your DNA. But now please let it out. There goes all the nitrogen. You don't get to breathe it. You're swimming in nitrogen. It's almost everything in the atmosphere. It's totally critical to life as an element. And the way that you're swimming through it, you don't get to use it. I had a friend in university who worked as a bank teller. And he would tell me, really frustrating, today I handled $2.5 million, and I took home $11 an hour minus taxes, $47. And we would laugh about that, how he's swimming in money when he goes to work, but of course that's not actually his money for him to use. Like nitrogen. Like a bank teller working at the bank, it's not your money. So all this nitrogen that we're swimming in, remember it's called atmospheric or diatomic or molecular, it's not usable for you. There's almost nothing on this planet that can use nitrogen gas. There's a very small group of bacteria that can break it up. Otherwise, all other life needs nitrogen, and all other life can't get it on its own. Have any of you heard of Hofbrinkel, the diatomic gases? Hydrogen, oxygen, fluorine, bromine, nitrogen, chlorine? I don't think they're noble. I think they're diatomics. The same thing? I think not. Okay, apparently you haven't had much chemistry, but Hofbrinkel are atoms that need to be in a buddy system. So you never write H for hydrogen gas, it's always H2. When you have oxygen gas, we don't write O, we write O2. See? And so nitrogen, it's never found on its own as an atom, it's found in this buddy system. And when two nitrogens are holding on to each other, they really don't want to bond with anything else. They're in a happy couple. They're fully committed. So they don't interact with other stuff. So we're all swimming in nitrogen gas and we just can't use it. Does anybody know where we get our nitrogen compounds from? Stuff that we eat. Plants are the only thing that can absorb ammonium. They use that to build protein. And we eat protein to build human. Does anyone in the room remember the building blocks of proteins from biology?
Amino acids and the carbon sugars.
Nope. Proteins are built from amino acids, that's right. Amino acids. Do you remember how yesterday I did this to make glucose? Yeah. I'd like to change what this pen means now. I'm too cheap to buy nice demos. So this was glucose yesterday. Today, it's a protein made of 1, 2, 3, 4, 5, 6 different amino acids. Keep in mind, there's 20 amino acids in life. We only need about 17 of those to be humans. The other 3, they're not really useful to us. So we call them the essential amino acids and the non-essential amino acids. If I eat some cow, those are the amino acids that were building the proteins of cow. But I'm not trying to build another cow. I'm trying to build pure, glorious Argentinian sex appeal. Raw man. So when I eat a cow, I go, and inside my gut, the amino acids are disassembled. So I've taken apart the cow proteins. I will reassemble these as perfect sex appeal. And anything left over that I don't really need to build God in human form, then all those other amino acids that were used by the cow but not used by me, I will get rid of, depositing them in the porcelain receptacle. Watch. All proteins are built by plants. All consumers get those proteins by eating the plants, and in our gut, those proteins get digested into the amino acids that we incorporate and the amino acids that we get rid of. Are there any questions about what I've said so far? Yes?
The protein
Uh-huh.
from the plant,
Uh-huh.
does that contain ammonia? And that's how we get it? Or it's broken down and then turned into protein?
Neither of the things that you said are accurate. So, proteins are made of amino acids. They're like the blocks that assemble into protein. We break that up into amino acids, build different proteins, And we have some leftover amino acids, we prep those up. By the way, is anybody here a vegetarian or was a vegetarian but went back to meat? Or knows a vegetarian who was a vegetarian and went back to meat? What happens to a relapsed vegetarian the first time they eat meat? Yes?
You get really sick.
Yeah, what kind of sick? Like cold?
Yeah, you like throw up.
Stomach funk, right? How many of you have heard of this concept? So check this out. The breakup of proteins is done by bacteria that live in your gut. When I was a vegetarian for 11 years, I lost the bacteria in my gut who digest animal protein. When I went back to eating meat, I started with like a 1.4 pound steak. That was like the size of like a Webster's dictionary. It was glorious. It was like raw, like so much meat. I was in Argentina and trying to explain to my grandmother that I don't eat meat was just too complicated. She just couldn't like. I was like, nothing with eyes, Grandma. She's like, fish have eyes? Like chicken, right? I'm like, no, they have eyes, Grandma. But they're a different kind of eyes. Can I make you some chicken? Oh, Grandma. So I went back to eating meat and I was really worried. As it turns out, my gut of steel could take it. But the fear is that the meat will just sit in your gut and literally rot. As if you chopped it up into little pieces and mixed it with mashed potatoes and soda and then left it in a bowl covered with saran wrap at like 98.6 degrees on your countertop. That's what happens in your gut. So a lot of people, the first time that they eat meat again, everybody knows, they'll either blow chunks or blow fire hydrant. And there's a reason I mentioned those bacteria. Because pretty much all the nitrogen transformations are done by bacteria. Breaking the nitrogen bonds between the amino acids is done by bacteria. And then all of the stuff underground is done by bacteria. That's the answer to today's warm-up. It's all bacteria. So I'd like to look underground now. Under the ground, there's 1, 2, 3, 4 different chemical reactions that are all done by bacteria. There's a thinking challenge for my high school students. Whenever you see arrows and stuff, you kind of assume that it's like steps 1, 2, 3, 4. So this happens, and then this happens, and then this happens, and then that happens. But that's not what I'm trying to represent here. This is probably worth putting into your notes somehow, because I need you to shift this frame of thinking. These are not sequential 1, 2, 3, 4 reactions. They're just a cluster of things that happen independently in the same environment. If you go to a high school, there's probably somebody falling in love and probably somebody saying mean things about another person, and there's probably somebody at the high school who's feeling left out and somebody at the high school who's really excited to be included. Those are not sequential. They're just different things that happen when you have a lot of humans around. So, please look up. When you have a diversity of bacteria, different reactions happen to different compounds. That's not the whole picture. For example, that process is called denitrification. That's not the entire life of the bacteria. Keep in mind, you don't just turn oxygen into CO2. You have a whole nasty, disgusting private life and a public life and an intellectual life and an emotional life. And in part of your life, it's also true that oxygen gets turned into CO2 as like one of the things that your body does. Do we agree with that concept? So, these bacteria, that's not their entire life. They don't live for one reaction. These are bacteria that run around doing bacteria stuff, and they make out with other bacteria, and they give birth to little baby bacteria. They get chased around by other bacteria. And then one of the things that they do is this chemistry. We call these, and I'll come back, but first get them down. We call these denitrification, nitrification, ammonification, and nitrogen fixation. The word below denitrification? That is NO3, which is a nitrate into nitrogen gas, and that word is anaerobic, meaning that bacteria do this in the absence of oxygen. First of all, each bacterial species is separate. So denitrifying bacteria, they turn nitrate into nitrogen gas, and that's one species. And by the way, they're very unique. They live in places that have very, very low oxygen levels, anaerobic environments. There's a separate, different type of bacteria called nitrifying. They live in highly oxygenated environments. They turn ammonium into nitrate. These are all bacteria, yes, that's right. You realize that there's some unknowable gazillion of different bacterial species. Science so far hasn't really nailed down how to describe them even. And each of those different types of chemistry is done by a unique group of bacteria. There's like a... That's right, that's right. So there's like a number of species that do this job. There's a number of species that do that job. There are other bacteria called ammonifiers or ammonifying bacteria. They change aminos into nitrate. And finally, there's one that's super important we'll have to come back to. They're called nitrogen-fixing bacteria. They turn the gas into ammonium. That's the only group of species on Earth that can biologically use nitrogen gas. It's the only group of species, the only life on the entire planet that can break nitrogen and use it to do something different, starting with nitrogen gas. That work out? Awesome.
Do they only live in root nodules? Is that the only?
No. Look at what these bacteria does, and then I'll tell you something really cool about plants. Nitrogen-fixing bacteria are found in shallow water, in soil, and inside the roots of some plants. And they make ammonium, which everybody here has to know is the primary plant nutrient. It's the number one fertilizer. It's the most important, most basic plant fertilizer.
You say they live in the roots of all plants, or
Just some.
just some?
I think so. A few little details. I want everybody to remember that this is the primary fertilizer. So unfortunately, I have a horrific reference which some of you might already know. Does anybody know something very dangerous and sketchy that you can do with ammonium?
Makes it explode.
As a matter of fact, you can make really toxic gas, yeah, but you can also make homemade bombs out of it. I'm not really sure what the chemistry is, and I wouldn't encourage you to play around to find out. But there was the deadliest terrorist attack in U.S. history before 9/11 was a white dude, some militia, government separatist weirdo, who took like a pervert van, like a big van with no windows, filled it up with like 4 pallets of fertilizer, did some like creepy, freaky chemistry that I don't understand, drove up to the federal building in Oklahoma City, Oklahoma, started the timer, walked away, it blew up, and like the front half of the building fell down. It was like a 12-story building. It was super tragic. Many people died. I believe the Unabomber used to send bombs, right, in the mail. There's another crazy white guy. Yeah. There's a few reasons that I mentioned this. One, because I think that we've all become convinced lately that all terrorists are one color, and I strongly encourage you to reject that. Separately, though, I want everybody to remember that what he used was a nitrate bomb. Sorry, an ammonium bomb. That's this stuff, ammonium. Plant nutrient, fertilizer. It's the stuff you buy in bags to feed, like Miracle-Gro, the little sticks that you put in a little potted plant. That is largely ammonium. Plants absorb that from the ground. They assimilate the ammonium from the ground, and that's how they build the proteins that we need to eat. Cool thing about those plants, does anybody here, who's currently a vegetarian? And do you know vegetable foods that you're supposed to eat to provide your protein needs? Like what? Soybeans is good. Anybody know other things? Legumes in general. Yeah, other big seeds like beans and peas and stuff. Anybody know other things? Lentils, pretty big seeds.
Oatmeal.
What?
Carrot oatmeal.
Yeah, especially if it's a whole grain, big seeds. You'll notice all the stuff I'm talking about is big seeds. Here's why. You need protein for life. Whenever you make a seed, you're packing a bag for your offspring to use. You realize that it's genetic material for your child wrapped up in food. That's what seeds are. Right? So you throw a seed into the ground and that little genetic material has all the food it needs to start being a plant on its own. It's like when you go off to college, your mom and dad deliver your car with all kinds of crap from Costco. That's like a seed. So you make a big old seed, it's going to have a lot of protein to make a big old plant. Watch this. If you need to build a lot of protein, you're going to need a lot of which nitrogen compound? Ammonium. So, plants that make really big seeds, they need a lot of that bacteria around, right? To take nitrogen gas and make all the ammonium, right? So they provide a home, they're called root nodules, for bacteria. There are plants who house high levels, high concentrations of nitrogen-fixing bacteria. Those are the plants that have the most protein because they have on-board bacteria dedicated to making their ammonium. Have you heard of people, or do you know people, or are you one of those lucky people who has like a live-in chef that makes food, like full-time?
I had one for like a week.
Yeah, I've heard of people who do this. I know some families who do this. And like, oh my God, to like come down to the kitchen and have like awesome meals made and not have to like get your hands dirty and waste your time and do dishes, that sounds so nice. Well, that's what these plants do. They provide a home for their nitrogen chef to make a compound that they can absorb. They're called root nodules for nitrogen-fixing bacteria to live in those roots and provide the plant with ammonia. I'm almost done. I just want to check for questions before I do the last lap. Yeah.
So the bacteria benefit, other than like that housing, how,
Yeah.
how do they benefit from fixing nitrogen?
Well, you got to remember that's just part of being that bacteria. So for all I know, and I'm not a specialist on this, that could just be a byproduct of doing other stuff. Like, how do you benefit from oxygen becoming CO2? Like, that's part of how you get your energy from breaking up some other compound. That's just part of doing what humans do, right? So these bacteria have complicated metabolisms with a whole bunch of different chemistry, and we're just paying attention to how they transform nitrogen. Okay, kids.
Let's see. Such a nutsack.
Didn't see that coming at all. All right. Nitrogen-fixing bacteria are the ones that fix nitrogen from nitrogen gas to ammonium, the primary need for plants. Some plants house them in their roots. Questions about that? Cool. There's a few other bacteria in the ground that are all involved in separate nitrogen chemistry as part of their complicated lives and the part that we keep track of. Ammonifiers turn amino acids into ammonium. Nitrifiers turn ammonium into nitrate, and denitrifiers turn nitrate into nitrogen gas. These are all different species. Some places have a lot of one, some places have a lot of the other. Sometimes one comes after the other. They're different species. But in the ecosystem of the soil, these different reactions happen with nitrogen. Yes?
How exactly does the gas hold nitrogen?
How exactly is what?
How exactly does the gas hold nitrogen going into the ground?
All I can tell you is this is a small part of the metabolism of that plant, and there's gas in soil. You realize that soil has little tiny air pockets? So the reason that farmers fluff up their soil is so that it absorbs water and exchanges gases better. Farmers like light, fluffy soil so you can deliver more atmospheric gas to the bacteria underneath, just kind of encourage that food web. This is also why we like turn compost and stuff, just to like get hits of gas to feed those bacteria and give them a chance to do more of their chemistry. And this is just one part of their this is not a balanced reaction. There's all sorts of inputs to that bacterium and all sorts of output. This is how they change nitrogen. I don't know the rest of their whole biological life.
So if every time we breathe in it's 71% nitrogen gas, why don't we have those nitrogen fixer bacteriums in our lungs?
That's like saying, why haven't we evolved wheels or wings? That would be so nice. Like, it's just, I don't know, man. It's one of those things that, like, evolution's not perfect, and it's like, we haven't answered all problems. That would be a really good one to solve, though. Now, I've got one last detail, and then we're done. Pick up my one last detail. I want to review. You should have written this on your paper, unless your name is Jack, in which case you don't believe in paper. I'm sure that'll work out. Everybody should have this in their paper. What is the nitrogen compound that plants absorb to build their proteins? Ammonium. Look at this. Nitrogen fixers make ammonium, but does anybody see ammonium somewhere else on the whiteboard? Where? In ammonification, right? When poop decomposes, leftover amino acids decompose to make ammonium again. Here comes the key observation that some of you are missing because you're trying to help each other with notes. You can always get them from me later, but hold on, watch. Amino acids in poop decompose into ammonium also. So that's why I said two-way street. Are you all aware that poop can biodegrade into fertilizer? You can make manures. Here's why. Leftover amino acids in poop ammonify into that ammonium that the plants need. So there's two main sources of ammonium on the whiteboard. The bacteria that fix it, and the decomposition of amino acids in poop into ammonium also. There's two ways that you can feed the plant with ammonium. And coincidentally, nitrogen fixers, if there's no plant around, that ammonium is still left in the soil, and that can be used by these bacteria. It's a two-way street, so the ammonium can come this way or that way. We have the nitrogen stuff above soil, the nitrogen stuff below soil. All the chemistry is done by bacteria. Yeah,
I'm confused about the gas form and how it's coming
sure.
out of the soil into the air.
Okay, so you realize that gases float. They're highly active molecules. So as soil is mixed up, any gas molecules that are knocked around will just rise against gravity because they're more active. And that's how it works.
Okay.
Yeah, it's not like a giant chimney like shooting it out. It's just like whenever soil is disturbed, little bits of nitrogen gas come out. What else?
What
Yeah.
property is ammonium in? Is it
Liquid. 'Cause it's an ion. So it's dissolved ammonia. And if you want to correct me on that, I might be wrong. It's been a long time since I had chemistry, but I think it's in water. What else? I think ammonium is ammonia dissolved in water. Yeah. Lithosphere. Sorry, hydrosphere. It's in water. Yeah.
Wait, so denitrification turns nitrate into nitrogen gas, and then what else does?
Correct.
acidification?
What else is what?
What does like ammonification and acidification?
Ammonification turns aminos into ammonium.
Okay.
Nitrification turns ammonium into nitrate.
Okay.
Yes.
Is ammonia and ammonium the same thing?
Basically, one of them is in solution, the other one is not. So if I'm not mistaken, and bro, don't take this, I'm out of my league. I don't get, it's like above my pay rate. But I think ammonia is a crystal, and ammonium is what happens when you dissolve that in water. Somebody who knows chemistry better can correct me, but I think that's right. Okay, children, I'll see you tonight.